Here we are simplifying or collecting like radicals. And right now, these do not look like they're like radicals because one is square root of 24, the other one's square root of 54. However, each of these can be simplified. We're looking for factors of 24 that are perfect squares. And 4 times 6 is 24. Plus, looking for a factor of 54 that's a perfect square. And we have 9 times 6. Now there are other factors of both 24 and 54 and some that are perfect squares. However, we need the biggest perfect square. This 4 that's inside becomes a 2 outside. This 9 that's inside becomes a 3 outside. I'm going to kind of skip a step because of space reasons here, but basically now we have 10 root 6 plus 21 root 6, which is 31 root 6. This next one, we have a variable now. It's not really any harder though. Looking for a factor of 48 that's a perfect square. 16 times 3 is 48. Looking for a factor of 75 that's a perfect square. 25. I'm using the dot for the multiplication there. This 16 that's inside becomes a 4 outside, making that 32. I'm kind of doing this in one step. This 25 that's inside will become a 5 outside, making that 25. And now I have 32 root 3x minus 25 root 3x. That's going to become 7 square root of 3x. This time we're dealing with cube roots. We're looking for factors of 16 and 54 that are perfect cubes. Things like 8 and 27 and 64 and 125. (16) is 8 times 2. 54 is 27 times 2. This 8 that's inside will become a 2 outside, making this 10 cube root of 2. This 27 inside becomes a 3 outside, making it 6 cube root of 2. 10 cube root of 2 minus 6 cube root of 2, this is just like terms, only it's like radicals, becomes 4 cube root of 2. Notice my index is always sort of inside that little crook, so to speak. It's inside there. And the last one, cube root and variables inside here. Oh my goodness. (81) is 27 times 3. And then x to the 4th, I'm going to break that down into x cubed times x. (24) is 8 times 3. Again, 8's a perfect cube. Now, 27 and x cubed are going to come out. The 27 inside becomes a 3 outside. The x cubed inside becomes an x outside. I'm left with 3 and x inside the cube root. This one, I've got the 8 inside, cube root makes that a 2 outside. And think of this and this as like terms, only it's like radicals. I'm going to wind up with 30x minus 6 times the cube root of 3x. You can, if you like, I wouldn't say this is mandatory. I could have looked at this and said, you know what, each of those has a common factor of 6 cube root of 3x. And what happens if I divide this term by 6 cube root of 3x, I would be left with 5x. When I divide this by 6 cube root of 3x, I'm left with 1. I could write it like that. And hopefully you see that this times that is the same as this. Either one of these two answers would be totally good.